So here we have a situation. So in this first part, he is saying that a block of mass half kilogram is placed on a long slab of mass 3 kilogram as
Yeah.
shown above. So here it is shown. Initially the slab is at rest and the block has a speed of 4 meter per second to the right. The coefficient of kinematic friction between the block and the slab is 0.2, and there is no friction between the slab and the horizontal surface on which it is moving. Okay, so here we have friction and the coefficient of kinetic friction, that is given as 0.20, and here there is no friction, right? So in the first part, what he is asking that on the dots below that represents the block and the slab, draw and label vectors to represent the forces acting on each as the block slides on the slab. So the left dot is for the block and the right dot is for the slab. So what are the forces that are acting on the block? So what are the forces acting on
There's
it?
friction and there's normal
So,
gravity and
first of all, we will draw the arrow for the weight
yeah.
of the block. The weight of the block will be the mass of the block times g. Another force that is acting on the block will be the normal reaction exerted by the slab on the block, and the third force, that will be the force of friction. Okay, and that will act in the direction opposite to the direction of relative motion, means velocity of this block with respect to this slab is 4 meter per second towards right, so the friction will act in this direction, right? Now what is the situation for the slab? So mass of the slab times g, also mass of the block into g, means because this block is placed on
Yeah.
this slab, so the mass so the weight of the block is also acting on this slab. Another force that is acting on it is the normal reaction provided by the surface on which the slab is placed. Okay, and it will experience a frictional force in this direction, right? Is that okay?
Yeah.
At some moment later, before the block reaches the right end of the block, both the blocks and the slab attain identical speed vf. Then you have to calculate what is the final speed. So what you can do, you can consider this arrangement as a system,
Yeah.
right? So initially the slab is at rest. Initially this slab is at
Yeah.
rest, but when it is projected with a velocity of 4 meter per second with respect to this slab, so the force that is acting on the block, that is the force of friction in the backward direction, but there is a force that will act on the slab in the forward direction. So no external force is acting, and in such a situation, so for B we can say that in this given system no external force is acting. So when no external force is acting, this means what? This means what? Momentum of the system will remain
Conserved. Yeah.
conserved. Momentum of the system will be conserved. So what is the initial momentum? Initially we just have the momentum of the
Yeah.
block, and finally we have the mass of the block plus mass of the slab So basically what is happening, even if you have made this block to move with a speed of 4 meter per second on this slab, but friction is acting on it, and ultimately a situation will reach where the relative velocity of this block with respect to this slab becomes 0. So in such a situation, okay, so both will move with the same common velocity. Here it is, here he is saying na, both the block and the slab attain identical speed. Okay, this means it has come to rest with respect to this slab here. So from here what we can write, the final speed of the combined mass arrangement, so that is the mass of the block divided by the mass of the complete system times V naught. So substitute the values, that is 0.50 kilogram, 0.503 kilogram, and the speed is 4 meter per second. So if you solve it, so that is 0.57
yeah.
meter per second.
Yeah.
Right? So that will be the speed. So what we have done here we have used the concept of law of conservation of linear momentum. But before that we have assumed that both these block and the slab are in a system. Now in C part, B part is answered. C part, calculate the distance the slab has traveled at the moment it reaches Vf. So what is the distance traveled by the slab? So how will you do that?
Distance traveled by the slab. So we can find the acceleration of both the block and the slab.
So why there is an acceleration?
Because the block is sliding on the slab, right? Past each other.
So because so then if the block is sliding on the slab, then due to which phenomena the slab will move?
Friction.
So friction is acting on the
Block.
Friction is acting on the block
Yeah,
and the
both.
slab also. We are considering the motion for the
Yeah.
slab now. We have to calculate the distance
Yeah.
traveled by the slab. So initially the slab is at rest. The final speed of the slab, initial speed of the slab, that is to the acceleration that the slab will undergo and the displacement by the slab. So we will use this equation. So we can write this as, because this is 0, so we can write Vf square by 2a, right? This a is what? Acceleration of the slab, no?
Yeah.
So Vf we have calculated from here. Vf we know, but we don't know that what is the acceleration of the slab. So our first objective to answer this section is to calculate the acceleration of the slab. So how will you find the acceleration of the slab?
For the slab, you can do the
So frictional force is responsible
frictional force divided by
for
mass, right?
so frictional force is responsible for the acceleration of the slab. So the friction force is equal to what? Mass of the slab times acceleration of the slab. Now we have to find this force of friction from the other given data. So the same force of friction is acting on the block also. So we can write the force of friction as what? Mu k times the normal reaction. Normal reaction corresponding to the block. So what is the normal reaction corresponding to the block? That is mass of the block times g, that is mass of the slab into as. So AS is equal to mu K. What is mu K? 0.2. Mass of the block 0.5 into 10 divided by the mass of the slab. The mass of the slab is 3 kilograms. Right? Clear?
Yeah. Yeah.
Hello. So what you can write from here? Calculate what is AS, the acceleration of the slab. What is the acceleration of the slab? Or you can simply put it here also, or you can calculate it.
Yeah.
So that is 10 by 3. It is 0.2. Recheck the values. 0.5, G is 10. So that will be 1 by 3. So that is 0.33 meter per second square.
Yeah.
Right? So if I substitute the value of AS here and VF from here, so what will be the displacement? Calculate. VF is 0.57 squared divided by 2 times acceleration. Check what will be the answer. Check.
Yeah.
Fast. What's the value?
0.327. 327 I'm
Point.
getting.
Recheck.
Check. Okay, 1 second.
It is 0.49.
0.488. Yeah. I was just checking.
So that is the displacement of what? This is the displacement of the slab.
Yeah.
Right? So that is the answer to part C. Now calculate the work done by the friction on the slab from the beginning of the motion until it reaches VF. So you have to calculate the work done by the friction. So which phenomena you will use? Very good question it is.
Work done by the friction.
A very simple and straightforward
Yeah.
situation. And I have told you many times.
Work done by the friction on the slab, right?
Or simply calculate change in kinetic energy.
Yeah.
So use the work energy theorem. So initial speed of the slab was
Yeah.
0. Final speed we have calculated, that is VF. So that is half ms, that is the mass of the slab, times VF square. So that will be half. Mass of the slab is 3 kilograms. VF we have calculated 0.57
Yeah.
squared.
Yeah.
Okay. Now this is, solve this. 1.5 times 0.57 square. So what that will be? Check. What that will be? It is 0.49 joule. Okay, that is 0.487. So if we round off to 2 decimal places, that is 0.49. Clear?
Yeah.
Right? So that's not a difficult question, relatively very easy question it is. So here we have a situation. We are having a non-linear spring that is compressed various distances x, and the force F required to compress it is measured for each distance, and the data is given below, right? So this is the value of x through which the spring is compressed, and here we have the value of the corresponding force that is required to create that compression. So he is saying that assume that the magnitude of the force applied by the spring is in the form of ax square, right?
Yeah.
Which quantities should be graphed in order to yield a straight line whose slope could be used to calculate a numerical value for a? So he is answering by himself that he wants you to draw a straight line.
Yeah.
So which quantity should be graphed? So we are given the value of x and we are given the corresponding value of f, and the situation is given as this. So if you want to calculate the value of a in terms of the slope, this means this value must be plotted along y-axis, and you can plot this value along x-axis, right? Then a will be the slope, and that is a constant slope in such a situation, so that will give you the numerical value. So what you can do, you can calculate the corresponding value x square. Okay, so in B part he is saying the same. So calculate values for any of the quantities identified in A that are not given in the data, and record these values in the table above. Label the top of the column including the units. So if you square this value, so that would be meter square. So if you square 0.05, so that would be how much? 0.0025. Square of 0.1, so that is 0.010 of 0.15. So how much that would be? How much that would be? 0.225. So if I round off to 3 decimal places, so that will be 0.23. So that would be 0.040 and 0.25. So it is 625. So round off to 3 decimal places, so that would be this much. Right? So we have answered both part A and B.
Should I plot it or no need?
No. The question is ahead, na? C part. On the axis below, plot the quantities you indicated in A and label the axis with the variables and this appropriate numbers to indicate the scale. Okay. So definitely, as I have said, that you will plot this f along y-axis. So you will plot f in newtons, x square in meter square, right? And from here you can very easily check that that is 0.00, right? 25, 0.10, 0.2, 0.4, 0.6, right? So what we can do, we can plot it accordingly. So this is 0, this is 0.01, and this is 0.005, right? So similarly, if this is 0.01, so this is 0.02, this is 0.03, 0.04, 0.05, and 0.06, right? Okay. So initially our initial value when we have the situation for x equal to 0.05, but this plot is for x square, so we will look for the this column, so that is 0.0025. so this is 0.005. okay, so if we want to locate this point 0.0025, if I want to locate this point 0025, so that point must be somewhere here, the middle of this 0 and 0.0025, so it will be here, and the corresponding value is how much? Corresponding value of force, so that is 4. so on this scale, vertical scale, we have to draw, and it is varying up to 106, so we have to divide this scale in such a way that we can cover up these values. So what we can do, 1 2 3 4 5 6 7 8 9 10. okay, so if we allocate this 1 unit as 10, so then we can drop to 100, so we can write that this 1 is 10, this is 20, this is 40, this is 60, this is 80, this is 100, right? Now corresponding to this value of 0.0025, the value is 4, so this is 5, so it is somewhere here. This is your initial value, right? Next value of x square is 0.010, and the corresponding value is 17, so it is more than this value, it is somewhere here. okay, then 0.023, so it is somewhere more than this value, 0.02, and this is 0. You can say 0.25, this is 0.025, right? So 0.023 is somewhere here, so and we can take 0.025 corresponding value, or we can write this value here, so that is 38, so it is less than 40, so the point must be somewhere here, right? Next value is 68, and this is 0.04, so this is 0.04, and the value is 64, so it is somewhere here, right? Then we have 0.063, so and the corresponding value is 106, so it has to be more than 100, and it is somewhere here, right? Now what we have to do, we have to try to join, or we will use best fit method. So if you try to draw a line, okay, so this is almost a straight line, okay, so that is required, that we want to plot f versus x square, and if we try to and if we want to calculate the value of a, right, so that is the slope of this line. And the d part, he is asking that using your graph calculate the value of a. So correspondingly you can consider any two values. Suppose I am considering this value, so this point is representing what? That is corresponding values are 0.023, and other value is 38, and this point, next point, is how much? That is 0.04068. So the value of a you can calculate from here, will be change in y by change in x, means change in f 68 minus 38 divided by change in x 0.040 minus 0.023. Find the value of a, solve it. Check. Because we have just drawn the approximated
Yeah.
value, okay, there is a probability that this line might cut any one of the exact points, just like here or here. Okay, so because we don't have the scale and we have just drawn it not with that much precision, so if you try to draw this with precision, so you will get the exact markings on the graph also, but still you can try that. Check what are the values you are getting.
So I am getting 1304.
That
04.
3,
0.35.
so that is 30, and that is 0.040 minus 0.023, so that is 0.017, so that is 30 divided by 0.017. How much you are getting? Why you are carrying out wrong calculation?
1304.35.
Alright, it is 1.7 into 10 raised to power 3 Newton per meter square.
Yeah.
Right? This will be the value. So because we are interested in calculating the slope, na? So that's very simple. Next part of the question. The spring is then placed horizontally on the floor. Now basically now we have calculated A, so we have to use this here. Hopefully the spring is then placed horizontally on the floor. One end of the spring is fixed to a wall. Okay, one end of the spring is fixed to a wall. A cart of mass half kilogram moves on the floor with negligible friction and collides head-on with the free end of the spring. Okay, a block of half kilogram is coming from this side and it is colliding with the spring and hence compressing the spring up to a distance of 0.10 meters.
Yeah.
Okay, suppose it is compressing it by 0.10 meter. Calculate the work done by the cart in compressing the spring from its equilibrium length. Now we know that work done by the spring force is equal to what? Or you can use the basic formula for the work done, so that is equal to F dx, because force is variable here. Okay, so force is what? Ax square dx, and the spring is compressed in this range. So A we have calculated, so that would be x cube by 3. Lower limit is 0, upper limit is 0.10. So just substitute the value of A, that is 1.7 into 10 raised to power 3 x cube. So that would be 0.10 10 raised to power 3.
Yeah.
Okay, now if you solve it, you will get 0.57 joule.
Yeah.
Right? F part. Calculate the speed of the cart just before it strikes the spring. So very simple. Again we will use work energy theorem.
Yeah.
So work done is equal to change in kinetic energy, right? Work done is equal to change
Kinetic
in
energy.
kinetic
Yeah.
energy. Okay, so work done by the spring, that will be the negative value. Okay, work done by the spring force, because the spring is compressing in this direction and the spring force is acting in this direction. Or simply you can write directly also as the work done that we have got, that is 0.57, and the initial kinetic energy is equal to what? Half m. M is how much? What is the mass? Half kilogram. V square, so V square is equal to 4 into 0.57, so V will be equal to 4 into 0.57, right?
Yeah.
So solve this. We will get 1.5 meter per second.
Yeah.
Right?
Yes,
Is that
sir.
okay? Read this question. So here we have a thin loop of mass m, radius r, and the rotational inertia mr
Yeah.
square. It is released from rest from the top of a ramp of length L. The angle is theta, and the table is at height h above the floor. Assume that the hoop rolls without slipping.
Yeah.
Down the ramp and across the table. Express all the algebraic answers in terms of the given quantities and the fundamental constants. Okay, so there are various methods using which you can solve this problem. Okay, either you can use the rotational dynamics method. Okay, you can use this conservation of energy and all that. So there are various ways you can answer this question. So I am using the shortest way, that is the law of conservation of mechanical energy.
Yeah.
Right, now see, it is moving from this top to the bottom. So in part A and B, what we have to derive? We have to derive expression for the acceleration of the center of mass and the expression for the speed of the center of mass when it reaches the bottom. So we will start with part B. Okay, so by the time it reaches here, so all of its energy will get converted into what? The kinetic energy. So if this is L, so what is this height? What is that height?
Height is
That is L sine theta.
yeah.
Now comparing this level and this level, there is a change in potential energy,
Yeah.
and this change in potential energy gives rise to the rotational kinetic energy plus the translational kinetic energy of the loop. So what is the change in potential energy? Assuming this has the lowest level, so we can write that the potential energy is mgl sine theta. By the time it reaches here, suppose it has gained a velocity v, the rotational kinetic energy we can write as half I omega square, because it will roll, so it will attain certain angular velocity omega also, plus translational kinetic energy, that is half mv square.
Yeah.
Right? Now as it is rolling without slipping, so we can simply write omega as v by r. So we can write this as half mv square, right? Okay, and also the moment of inertia is given as what? Mr square. So that is mr square v square by r square half mv square mgl sine theta. So this r square and r square would can cancelled, half mr square plus half mr square mv square, so that is equal to mv square. This m and this m will get cancelled, so simply you will get v as gl sine theta. So that would be the velocity of the center of mass the time it reaches on this platform.
Yeah. Yeah.
Okay. Now write an expression for the acceleration of the center of mass of the hoop as it rolls down the ramp. Okay. Now initial speed is what? 0. So simply use this equation, v square minus u square equal to 2as. This is 0. Final speed we have calculated, and square of that is gl sine theta. 2 acceleration of the center of mass, and how much displacement this loop has done, that is L. So that is L. So acceleration of center of mass will be g sine theta by 2. So that's the acceleration of center of mass.
Yeah.
Clear? C part, you have to derive an expression for the horizontal distance from the edge of the table where the loop lands on the floor. Okay, so that's very simple, because it has attained a velocity v, so it will act as a horizontal projectile. So he is basically asking this distance horizontal range, so that is very simple. So r would be equal to what? V into time of flight. So what is time of flight? That is 2h by g.
Yeah.
Clear? And v we know here, so that is equal to gl sine theta into 2h by g. This g and g would get cancelled, so the range or the distance through which it will fall, that will be equal to 2lh sine theta.
Yeah.
Right? D part, suppose the hoop is now replaced by a disc having the same mass m and radius r. How will the distance from the edge of the table to where the disk lands on the floor compare with the distance determined in part C for the hoop, whether it is less than, the same, or greater than. So this is a very simple question, not difficult. The only thing that will change is for the moment of inertia. For the loop, the moment of inertia is mr square, but for the disk, the moment of inertia will be equal to half mr square. So that moment of inertia will become half. So here we will get an additional value of 1 by 2, right? So when we get 1 by 2, so that is 1 by 4. So that will become 1 by 4 plus 1 by 2. So how much that would be? 6 by 8, 3 by 4,
Yeah.
right? Okay, so this means the speed would be lesser. So V in case of disk will be less than V in space in case of loop. So when this V is less, the distance through which it will fall will also be less.
Yeah.
Okay. Or greater than. Check. See, that will become how much? That will become 3 by 4 mv square,
Yeah.
right? And when we write V, so that will become 4 by 3. So this speed is greater, not
Yeah.
lesser.
4 by 3
So
GL
this
sin
speed
theta.
is because we have to write
Yeah.
V na. So V will be 4 by 3. So this speed is more. So when this speed is more, so this distance covered will be greater than. So answer will be greater than. Okay,
Yeah.
right? So try questions yourself. Take any paper of previous year and try to solve this.
Yeah. Yeah.
Okay. So in the next session we will do some questions from SHM from the Resnick-Halliday
Yes.
part.
Yeah.
Okay.
Yeah.
Okay,
Thank you, sir.